We are on 7.5. Apply properties of logs. So we have 3 new properties that we're going to learn today. Remember, we learned a few the other day in 7.4. These are going to be a little bit more in-depth. So properties of logs. Let B, M, and N be positive numbers such that B is not equal to 1. So we have, like I said, 3 properties. So the product property is log base B of M times N is equal to log base B of M plus log base B of N. Now you may be saying, do I really have to memorize that? But what I think will help you to remember it, understand it, whatever, would be to say, this is the way I remember it, the log of a product is equal to the sum of the logs. The log of a product is equal to the sum of the logs. Say that over and over again, you'll remember it. The other property, or another one, is the quotient property. This says log base B of M over N is equal to log base B of M minus log base B of N. And there's a little handy-dandy saying to memorize this one as well. The log of a quotient is equal to the difference of logs. Log of a quotient is equal to the difference of logs. And lastly, there's a power property, and unfortunately I don't have a little handy-dandy saying to go with this one, but power property, log base B of M raised to the N is equal to N log base B of M. So this is being raised to something, we take that power and we stick it out front. That's all we do there. So those are your properties for this section that are important. And there is one other thing. It's the change of base formula that we need to go over. So do that, and then we'll go through some examples. Well, the change of base formula, if A, B, and C are positive numbers, with B not equal to 1 and C not equal to 1, then this is the formula here. Log base C of A is equal to log base B of C over log base B of, oops, sorry, I wrote these backwards. This one's supposed to be A and this one's supposed to be C on the bottom. Okay? So log base B of A over log base B of C. So when you're changing the base, you write your new base, and then it's the one that's higher up over the one that's lower, so A over C. And in particular, okay, the most common one we use when we change the base is base 10, so, or base E. So in particular, log base C of A is equal to log of A over log of C, and log base C of A is equal to ln of A over ln of C. Okay, most commonly we want to use either the common log or the natural log, so that's why we'll use the change of base to get it into one of those two options. So, let's start out with some problems here. Thought I had a sticky note with the problems I wanted to do on it, but apparently I don't, so I'm just going to look at these individually. Alright, match the expression with a logarithm that has the same value. We'll come back to that in a minute. You should be able to do those after we show the other example, so we'll come back to that shortly. Let's see. Let's go down to stuff like 15 through 30, and let's do those ones. That's honestly what I'm more concerned about. We actually probably won't do 7 through 14, and I might just go ahead and throw out 3 through 6 as well. I'm more concerned about you knowing this other stuff, so I think we'll do that. Okay, so coming down, stuff like 15 through 30, it says to expand. Okay, so let me go back in here really quick. These properties here go both directions. So you could also say the difference of logs is equal to the log of a quotient. So you could take it and you could have something like this, and you could condense it into this. If you're given this method, it'll say to expand it, which means it wants you to go to this direction here. So these first ones expand the expression. Alright, let's just start with 16. And try to give you guys several examples here to make sure we understand what's going on. So the ln of 15x, well, this is the log of a product. So, since I have the log of the product, it's equal to the sum of the logs. So this would be equal to the ln of, so I'm going to break it up into 15, plus the ln of x. So the log of the product is equal to the sum of the logs. And that's your answer right there. Let's see. 18. Log base 5 of x to the 5th. Well, this is, we don't have it being multiplied here, we don't have anything being divided, but we do have it being raised to a power. So this is the power rule, so we're going to take this 5 and we're going to throw it out front. So it's going to end up being 5 log base 5 of x. Okay, and this allows you to evaluate this. That's the point of throwing it out front. It allows you to evaluate. So when we actually get into solving logarithmic equations, it allows you to pull that out and then be able to just solve for x. Like say this was equal to something. Then we could solve for it and figure out what the value of x is. So that's why we want to pull it out front. I know it probably seems a little weird. You're like, why would you take the exponent and stick it out front? But that's why. And you'll see that more, I think, in 7.6. If not, then it may be next year when you get to pre-cal before you actually see it. But Let's see, number 20. We have the ln of 12 over 5. Well, we're not multiplying, but it looks like we are dividing. So log of a quotient is equal to the difference of logs. So you always write top minus bottom. So ln of 12 minus the ln of 5. And you have to have, this is something I didn't point out, you have to have this ln or log or whatever it is with every single number. Okay, it's not true. This is not equal to the ln of 12 minus 5. Okay, those are not the same thing. Don't do this. Don't do that. You have to write it this way. Okay? Because I know that's a common mistake that I see when people do these problems. Let's see, 22. So getting a little harder now. ln of 4x squared y. So we're expanding. So we want to get it out as far as possible. So something, we've seen it with 2 expressions up to this point, but now I have 3 things that I can separate it into. So it's still the log of a product is equal to the sum of the logs, but it's going to be 3 values instead of 2. This is going to be equal to the ln of 4 plus the ln of x squared plus the ln of y. Now, my question would be, are we done? The answer to that would be no, because we have a squared here and we have not expanded it fully. So the answer to this one would be the ln of 4 plus, we're going to throw the 2 out front, 2 ln of x plus the ln of y. And this here would be our answer for that one. Um, 28. Skip a few. Jump down to 28. So 28 is the ln of 6x squared over y to the 4th. Okay, so this is where it's really important to pay attention to the order that you do stuff. Okay? I see exponents here, I see multiplication happening, and I see division happening. So, the way I would recommend doing this, first of all, is that I would recommend you do the division part first. So the log of a quotient is equal to the difference of logs. So my first step would be to go ln of 6x squared minus the ln of y to the 4th. Because this way you don't lose things and you keep the signs where they're supposed to be. Because these subtraction signs are what can get confusing. So if we take care of this first, I know that's just going to hang out there. So now I can deal with this product that I have, and I can separate that. The log of the product is equal to the sum of the logs. So I can separate this into the ln of 6 plus the ln of x squared, and then I can bring all this down minus the ln of y to the 4th. Okay, so first I split the fraction. Okay, so I did the quotient rule first. Then I took care of the product rule. And lastly, I need to pull these exponents out front. So ln of 6 plus 2 ln of x minus 4 ln of y by the power rule. Okay, so you don't have to write these out to the side unless it helps you, but I'm just doing it so you can see where everything is coming from a little bit easier. Let's see, one last one out of this section, and then we're going to jump down into the condensing part, because I want you to see this. Number 30, log base 3 of the square root of 9x. Now, with one like this, we have to remember what a square root is. Okay, because I can't just immediately go, oh, well, this is a product, so I'm going to add them together. No. What we need to do is we need to think about this as log base 3 of 9x to the 1/2. And because all of that is being raised to the 1/2, I need to pull the 1/2 out front first. So 1/2 log base 3 of 9x. Now, I can do my log of a product is equal to the sum of the logs. So I did my power rule first. Oh. You did the power rule first. So now I can come down here on 1/2. But because this 1/2 goes with the whole thing, I'm going to bracket it off, okay, or parentheses, whatever. Log base 3 of 9 plus log base 3 of x by the product rule. And that would be the answer there. Okay, so that's expanding. Okay, and I know I just did a lot of examples, but I want to make sure you see a variety of stuff until you guys get used to them and everything like that. This will help you significantly. So now we're going to go into the condensing the expression. So we're going to be given something like this and have to get back to this point, basically. So condensing the expression. So start with something a little bit easy. 34, the ln of 12 minus the ln of 4. So with this one, now I'm going in reverse. So I have a difference of logs, meaning I have the log of a quotient. So this is going to be equal to, and remember it's always top over bottom, okay, when you write it out, so it's top minus bottom. So this is going to be the ln of 12 over 4, okay, which simplifies down into the ln of 3. Okay, so this would be what we were given kind of earlier in the problems. We would never have been given this because we wouldn't be able to break that up. But when we're simplifying these down, we have to write them as simple as possible. So I couldn't leave that as 12 over 4 because that can be simplified. Uh, 38. 5 log base 4 of 2 plus 7 log base 4 of x plus 4 log base 4 of y. Okay, so this one I'm going to have to write underneath for the sake of room. Ooh, sorry, my book is falling. Okay, now with this one is just like 36, but it's like one extra term, so that's why I went with this one over 36. So the first thing I need to do is I need to put all of these exponents back in here. So log base 4 of 2 to the 5th plus log base 4 of x to the 7th plus log base 4 of y to the 4th. Now, when I'm going to condense these together, okay, they're all adding, so they're all being multiplied, so I can go ahead and just write out each one of them here. So this is equal to log base 4 of 2 to the 5th times x to the 7th times y to the 4th. Now, this 2 to the 5th needs to be multiplied out. So this is equal to log base 4 of 2 to the 5th is 32, I think. So 32 x to the 7th, y to the 4th. Okay? And then we would just leave it there like that. Let's see. Let's go with 40, and then we'll go to the change of base stuff and be done. Alright, 40 is log base 5 of 4 plus 1/3 log base 5 of x. So, my first thing is I want to put this exponent back up top. So log base 5 of 4 plus log base 5 of x to the 1/3. Now, since it's a product, since it's adding, it's a product, so this is equal to log base 5 of 4 times x to the 1/3. But I need to rewrite this x to the 1/3 the proper way of log base 5 of 4 times the cube root of x. Now, technically speaking, I would take either answer, but your book does leave it this way. Okay, but I would take either one, so just so you know. Alright, now we're going on to change of base. So this is going to require your calculator. Alright, change of base is stuff like 45 through 60. Now, it doesn't tell you exactly what base to use, so you can really use ultimately whatever you want. I don't think it specifically matters, but we will go with probably just using the the common log. Though, like I said, I don't believe it matters. Just checking to verify that. They both give you the same, so we'll do a couple of each just so you see it actually. So they do give you the same, and they do not care which one you use. So, all right, 46. So quick refresher, change of base formula here. It doesn't tell us what base we want it in, so I'm just going to use this log of A over log of C all the way down, okay, or ln of A over ln of C, so we'll show both for some different problems. But 46 is log base 5 of 13. Now, this is where I will make a comment. The instructions specifically say to use this change of base formula. That does not mean that you can come over to your calculator, hit this log base, put in 5 and 13, and tell me that it's 1.59. Okay, can't do that. You have to use the change of base formula, and you have to show me your work for the change of base formula. What do I mean by that? You have to show me this is equal to log of 13 over the log of 5, okay, which is equal to whatever that's going to end up coming out to be. Or you could say the ln of 13 over the ln of 5. Either of those is acceptable, but you must show this step. Okay, or it won't be given full credit. Okay? So now I can come over to my calculator. I'm going to use my common log, so I'm going to use the log button on my calculator. So log of 13, and then I'm going to hit enter, divided by the log of 5, 1.59. And it doesn't say how many, so let's just go to 2 decimal places. So here, let's see, round to 2 decimal places. Okay, so this ends up being 1.59. Now, just to show you that it doesn't matter which formula I use, let's go with ln of 13 divided by ln of 5, 1.59. So it does not matter which one I pick. Either one gives the same answer, so pick your favorite. We'll do 56 and then we'll be done. We're not going to do anything like 57 through 60. So 56 is log base 8 of 32. So I'm using the change of base formula, excuse me, meaning top over bottom. So log of 32 over the log of 8. So over on my calculator, log of 32 divided by log of 8, 1.66 repeating, so 1.67 is going to be what we put down. Okay, and these that are just numbers, I should be boxing their answers. Alright, so hopefully that makes sense. Okay, I'm not as worried about change of base. I mean, it's pretty easy. It's just top over bottom. None of them are anything that you shouldn't be able to do. But remember, you have to show this step or they would be wrong, okay, on your quiz. If you have any questions about anything, let me know. Send me a note on Google Classroom, text, whatever. Those are probably the 2 best options at this point to do. Mainly because I can't check my email unless I'm at school, but as soon as you post on Google Classroom, I can see that right away because it'll notify me that there's a comment or something there. So, your homework is going to be day 41, every other odd. And I don't know if 41 is actually going to fall in there or not. I don't know the numbers off the top of my head if they'll fall in, but yeah, I don't think 41 will be in there, but anyways, that's fine. And then 45 through 55, every other odd. Okay, just so you get used to the change of base formula. Which actually, 45, 49, 53, this will stop at 53, so I'll just say 53. All right, have a great day.